Hello and good afternoon, people of YouTube. Today will be my first video on network automation. This video is more for my colleagues that I want to show what I'm doing from home, but if you take anything away from this, that would be amazing. So let's get started. Just to get the lay of the land in this video, I'm going to go over the apps and devices I will be using. So as you see, I have Visual Studio Code. This is my editor of choice for anything programming or networking related. Let's get rid of that. So here you can see a repository called CCIE_enterprise. So this video will be going over my CCIE enterprise journey. So I'm taking the INE videos that are about 100 hours long, and as I go along, I want to document, blog, and make videos of everything I'm doing in the meantime. Mainly to show my fellow colleagues, people at work, and documenting, blogging, and talking about it really helps you take in what you're learning. So again, I have this repository, and all this is Ansible. Yes, Ansible. We will be talking about Ansible today in my Ansible repository. Here you can actually see my GNS3 network topology. This is the INE's CCIE version 4.5 and now 1.0 routing and switching or enterprise network diagram. So I just copied theirs, right, because I'm following along with their videos. As you can see, there's 10 devices in here. So for this video of network automation, the thing I am focusing on is showing people how to baseline all your routers in one time go. As we know, when we're taking these videos that are 10, 20, 30 hours long, we go over a lot of different routing subjects: ERGRP, BGP, OSPF, RIP, and then we move into switching, HSRP, and all these technologies. So here I'm going to show you how to quickly baseline your routers so that when you're following along and the video starts out with already cleared routers, even though you just finished the OSPF one and now you're moving to ERGRP, you don't have to go through every router and type no router OSPF or no router ERGRP for every single router. This would be a quick way with the click of a button to baseline all your routers. So let's get started. First, I want to show you my actual Ansible repository. So what do we have here? We have all my hosts, and these are the routers in that network diagram I showed you in GNS3. And all these hosts have a role. Their own role is what Ansible calls it. As you can see, this is every router's host name. And in these roles, I have three main folders. Here we're going to focus on this Jinja2 folder, or file, excuse me, and this main.yaml file. As you can probably already guess, this is just a template for building a router's configuration, its startup config or its running config. So all these roles have the unique baseline of all these routers' running configs. So if we just do a quick comparison between our Chandler R10 router and our Phoenix router, which is the DMVPN hub, we can see quite the difference in configuration. This is the beauty of actually organizing all your routers into their own role. So now every router has its own unique baseline. So what good are these roles? Well, here we'll go to my actual playbook, baseline.yaml. Here we can see two separate tasks per se. The first task is we're actually going to generate configuration files. You can see here at this roles keyword that we're going to execute the files in each of the folders under roles. This will generate a configuration, and it will be sent on our local host, so our local repository. And all those configs that we generate by running this playbook we placed right here. As we can see, this is every single configuration for our routers. This is their baseline. So when I am going through INE's videos, I now have a baseline that I can use for the EIGRP, the OSPF, the BGP section, all the sections in the routing and switching. So let's look back at our VS Code. So what do we have in our configuration actually? We have IP addresses that will remain for the entire CCIE course in INE. And we have two applets. One applet we have here is baseline, which actually gets executed with an alias baseline. So I type in privileged exec mode baseline, and this applet will get run. This applet is getting rid of any routing process. And then it's copying a file from our flash, router.cfg, to our running config. So what is that doing? Well, once all this file is pushed, we do a copy running config to the flash. So once the baseline is pushed, immediately we get a good baseline stuck in our flash. So we can easily do this command right here. And now we have that good baseline always stored in our flash. Just something I do for a backup, let's say. So now that we have seen every router's baseline configuration, how do we actually send this baseline to the routers? Well, first thing we got to look at is our GNS3 topology. Here we have this NAT cloud. This NAT cloud has an IP address of 192.168.122.1. That is actually this laptop, this workstation that I'm working on's virtual IP address, and that is the default gateway out to the internet. So this NAT cloud is doing something Linux likes to call IP masquerading, which is essentially NAT. So any traffic sent here is going to be translated out to the internet from the source address 192.168.122.1, which is actually my laptop's IP address. So if we console into these routers, and we'll go to the router farthest away, and we ping the internet. Here we're pinging Google's DNS, we can actually reach out to the internet. Now, for anyone who's a network engineer, we know that NAT, or PAT in this instance, can take a number of devices on the inside network and reach the outside network. That is no problem. But let's get into this Boston router, the one actually doing the NAT. And let's look at our NAT translations. So let's send that ping again. And let's look at our NAT translations. So we can see our inside global address is actually gig1/0 on this router. And our inside local is going to be the R10 router's loopback address. Okay, so that's good. All of our routers can reach the internet. So if I had a server out somewhere in the world, I should be able to baseline using this repository, right, from anywhere in the world. Well, it's not exactly that easy. This router, our Boston router, actually has to employ a technology